Okay, in this example, I've got puzzle number 24 from Crazy Dad Volume 1, Book 100. And before I start, I want to remind that there's two conventions I use. One is that if I have two adjacent cells, one of which has to be a star, then I do what's called a binary star. I just indicate that. And that means that it's a star in this direction, but it's not a star in this direction. The other symbol I'll use is what's called a foursquare. These are four cells arranged in a square, and if they have to have a star, if it's guaranteed that there's a star in there, I indicate this way. So any empty, or I'm not sorry, one clear foursquare has to have, if it has this mark on it, it has to have a star somewhere in it. Okay. Now the first thing we need to do is search for freebies. To do that, I'm just going to take a ruler and run it across the diagram. Look for places where there are as many regions as there are rows or columns. So I'm up to here, and I've got 1, 2, 3, 4. I've got 4 regions, but in 5 rows, so that's no good. Start from the other side. There's a region. Okay. Now I have 1, 2, 3, 4, 5 regions and 5 rows. So these two can be deleted. They're not going to play into it. And in this direction, looking for regions again. Well, there's 1 here, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. And I'm on 1, 2, 3, 4, 5. I've got 6 columns displayed. So those regions account for all the stars. So any other entries into this are going to be deleted. So these can't have stars in them, nor these. And I'm going to pause for a minute. And so that takes care of the freebies. Those are ones that are just given to us. Next thing I notice is that I have here a foursquare, which is completely empty. It has no possibility of stars in it. And I'm going to count to find out what intersections it's on. I'll start the intersections here. 1, 2, 3, 4, 5 in this direction, and go up. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 and 9, depending on how you count this. Those are 2 odd numbers, so this is an odd, empty foursquare. Very, very important, very useful. It demands that this be a foursquare, this be a foursquare, this be a foursquare, and this be a foursquare. And it demands that this be a foursquare, this be a foursquare, this be a foursquare, and this be a foursquare. So we've already put down a fair amount of information, even for cells that look like they are completely blank. Here's a foursquare that has to have a star in it, and it has 3 cells marked empty. So here's where that star goes. It causes these guys to be emptied, but now I've got a foursquare, 3 of which are empty. That means this one is the star. So I finish out it. I now have a foursquare that's got 2 taken out, so there's a binary that goes in there. The binary sends 2 out on its other side, but here's a foursquare with 2 gone. That creates another binary. These 2 in a row here cancel and cancel, giving me a star here and a star here. And let me mark out the ones that they take out. So I've been able to put down 4 stars without any consideration of regions. Now this region here has got a binary, an empty one, and a single. So this becomes a star. and around it, cells empty out. And here I've got one of my favorite figures, which is I call 2 next to 4. So here's 2, and they're touching this 4. That goes like that, because these guys cancel the adjacent ones. Now I've got, in this direction, I've got 2 stars, a star and a star. So that gets rid of those and these. This is a 4 square, so this has to be a binary, and it cancels on its far side. And there's one here I forgot. And now, if we look across this row, we have a 4 star that needs to be completed, like that. That reveals this one as being the remaining star here. This star causes this one to cancel, produces a star here. 2 stars here cause this and this. 2 stars here cause this, this, and this. And you'll notice here in this particular region, we have 1 star and 1 empty cell. So this becomes the other star. It marks that. And in this row, we have a star and a binary. Okay. Now let's look over here. Here we have 1, 2, 3, 4, 5, 6 cells that are empty. That means that there are 2 binaries sitting here. We don't know which ones are going to become stars yet, but they cause the ones adjacent to them to be emptied out, both sides. Of course, this double star here would have caused them to be emptied out also, make that a star. And in this column, we only have 1 left. So this has to, 1 cell left, so that has to be a star. Now this star is touching this one, and this star is touching this one. So those all sold out. This region has got 2 stars in it already, so these guys go out. And in this region here, we have only these 2 left. There's a binary here. Next, I'm going to look at, here's an empty 4 cell, 4 square. Let's see if what its boundaries, whether it's an even or odd one. 1, 2, 3, so it's 3 over, and it's 1, so it's an odd. That's very powerful. It means it's forces 4 squares in both directions. These guys are already finished. So is this one. So is this one, but this one isn't finished, and this one isn't finished. This 4 squares got 2 already taken out, so it's a binary, and the binary takes 2 out, which creates another binary. Now, this binary and this star form 2 stars, so that goes out, as does that and that. This going out creates a star, which is adjacent to that one, so that star goes out. Now, let's see, what else have we got here? Yeah, this goes out also. So that going out creates a binary here. That binary causes that to go out, which creates this as a star. That's a double, 2 stars in a row that gets rid of that. Forces that to be a star, which is diagonal to this one. Forces this one to be a star. These 2 are in a row. It forces this one to be a star. This star here forces these 2 guys to go out, and again the two stars in this column force that one, leaving only this one. So a star goes here. These 2 stars cause that and force this, and we're done.